Hi, my name is Matt Duff, and today we're going to talk about stage order in active filter design. So when you do an active filter, it's composed of several first and second order stages. So for example, if you were going to do a third order filter, then you would make it out of one first order stage, one second order stage. If you were going to do a fifth order filter, then you would make it out of a first and second. You know, if you're going to do a sixth order, you'd make it out of 3 seconds, et cetera, et cetera. So each of these filter stages is going to have different characteristics. So if I call this filter stage A and this filter stage B and this C, the question is, does it matter if this is stage A is first or if it's last or in the middle? And the answer is theoretically no. So if in terms of theoretical performance, you're going to get the exact same magnitude response, the exact same step response. But as soon as you try to implement it in hardware, it does matter. And I think the best way to show that is to just use an example. So I've drawn up here on a board already, I've drawn up the characteristics of a sixth order Butterworth filter. So a sixth order Butterworth filter has 3 stages. The stages have a Q of 1.9, 0.7, and 0.5. And here's the shapes that each of these stages roughly would generate. So you can see, and this is typical of active filter design, is that one stage has a considerably higher Q than another stage. So let's say we were to implement this filter in hardware just the way it's shown. So we have 3 amplifiers, one for each stage, and our input signal for our first stage, where we send our input signal, and then our output signal has to look like this, which means that at our pole frequency, we're going to need an output signal that's 1.9 times our input signal. So that means that for the output range of the amplifier, we've got to set up voltage supplies for this amplifier so that it can handle basically twice as much as the input. Now, if you're trying to do a single supply design, you're trying to handle large input ranges, this can be a big deal. A better way to do this would be to use this guy as your first stage. So not only is it easy for him, because he's just attenuating, so he can actually have a pretty small output voltage range, but because he attenuates, if then, say, this guy is followed by this guy, so let's say we make this our second stage and we made that attenuation our first stage, because he's seeing an attenuated signal, he's not only seeing half the input signal, then even though he still gains up, his output range doesn't have to be very big. And so typically on the vast majority of designs, what you'll see is the reverse order of what we've got here, where you start with the low Q stages and build up to the highest Q last. And that way you get a nice voltage range. Also helps you avoid some slew rate limiting that you might get. Now, the only exception to this is if you're trying to do a low noise design. So typically, a rule for low noise design is that you want to put as much amplification as you can as early as you can. And so this Q, this stage is doing amplification, is making this peaking. And so we want him to be first if we were doing a low noise design. The other thing is that sometimes you'll do filter circuits with gain. That sort of complicates things a little bit, but you want to use the same sort of philosophy where the max gain, which is going to be kind of the combination of both Q and the DC gain of the circuit, you want to put that in terms of voltage range, you'll want to put that at the end. So that was hopefully a little bit of insight into how you might set the stage order of your active filter design.
Here's a demo of how you can use our Filter Wizard software to change the stage order. So go to the component selection, choose I want to choose, and you've got an accordion here, which now you can just change, and you can see how that change in the screen in the stages view. You can also go to, say, the noise view, and you can do the same thing. So you can change the stages and see how it affects the noise, or you can go to the voltage range view and do something similar.